Okay, this is the second to last lesson of the miscellaneous category. In your notes, this one is systems of equations. So we're going to have three situations. You're either going to have two situations that come together and they share a common solution. You're going to have two situations that when they come together, they have many solutions. Not any solution, but many solutions that they share. So if you look at this line, it's actually two lines and they share many, many coordinates. And then there might be two situations where they're never going to intersect. They're never going to come together. So when they do intersect, we say they're consistent, meaning they do have an answer. If they come together and they have an answer, they might have one or multiple answers. And if they have just one answer, it's classified as independent. Or if they have many answers, like here there's many, many coordinates, we'd say consistent dependent. And then if you don't have an answer, you're inconsistent. There wouldn't be a dependent or independent because it's not classifying the actual answer because there is none. So those are your three situations. Now you can solve a system by graphing, by using elimination or substitution. So let's just refer to graphing real quick. So I have a situation, two of them, and this is the equation for those situations. We don't know exactly what they are. And we're going to put these linear equations in slope-intercept form. So I want to get y by itself. So we're going to move x to the other side, now making it negative. And we're going to divide everything by a -1. So that's your first equation. So we're going to begin with b, and we're going to move with m. So we're going to begin with +4. We're going to go up 1 over 1, or down 1, left 1. And we're going to connect the dots. You want to graph as many as possible because if you're finding your answer graphically, you want your picture to be as clear as possible, okay? Really should have a ruler, but my other hand is holding my phone. Okay, and then this line, you have to get into slope-intercept form, so you move 3x to the other side, and you have +8 and negative slope. So we're going to get +8, and we're going to go down 1, 2, 3 over 1, down 1, 2, 3 over 1. And I'm only going to make a few because I found my intersection. That's your answer. So at 1, 5, that is your solution. When x is 1 and y is 5, these two situations are the same. So if you want to classify the system, you'd say this would be a consistent independent system of equations. I'm not going to do too much graphing. Another way to find a common solution is to use substitution. So you're probably going to use substitution and elimination the most. So substitution is when you take one equation and substitute it into the other to find the solution. You can't solve an equation when there's two different variables. But if you know that every time you see a y, you're going to replace it with 3x minus 7, then you take that one equation and substitute it into the other. So now it's not 6x minus 2y equals 12 anymore. It's going to be 6x minus 2, well, we said y is equal to 3x minus 7. So if they're the same, you can replace y with a 3x minus 7. Then if you go ahead and simplify, remember to distribute to both terms. Well, the x's are going to cancel or turn to 0, and you're just going to get 14 equals 12. And that's fine. But you have to ask yourself if that's true or if it's not true. If it's true, you'd have a situation like this. If it's not true, Therefore, there would be no solution. So if I were to graph these two equations, it would actually end up being parallel lines, and there would be no solution. So algebraically, it works out too beautifully. Okay. Now here, we are going to take one equation and put it into the other. Well, I don't have a y equals or an x equals, but I can create that. I can move this 3y to the other side. The x is still negative. We're going to remove the negative. So now each one's positive. So wherever I see an x, I can replace it with 3y plus 9. I don't have to get y by itself. I can get x by itself. Getting y by itself, you'd have to divide everything by 3, and that's not as nice as just getting x by itself. So that means wherever I see an x, 2y plus 5x equals 11. So wherever I see an x, I can replace it with 3y plus 9. Notice every time I put parentheses when I'm replacing. I'm doing that, so you should probably do that. It will help you out every time. And then we distribute. And then we combine like terms. And then we get y by itself. And then we divide, and y equals -2. But I'm not done. I want to solve the system, meaning I need to find x and y. So I take y and I can put it back into either equation, or this equation, doesn't matter. So yeah, let's just do it here. If I know y is -2, let's replace it, and we will get 3. So my solution is 3, -2. Okay. So we had no solution, and we had a solution, and we haven't done any with consistent dependent yet. An answer for that would be like if we got 7 equals 7, 0 equals 0, something like that. Okay, so let's try a word problem where this might make a little more sense than just here's a line, graph them, where they come together. So it says, in order for Jose and Marty to compete against each other, during the wrestling season, they need to be in the same category. Jose weighs 180 and plans to gain 2 pounds per week. So he's 180 and he's going to add on 2 pounds per week. Well, that's Jose, and then Marty weighs 249 and he plans to lose 1 pound per week. And how many weeks will they weigh the same? So when is this the same? So here's an equation, y equals, and here's an equation, y equals. One represents Jose, one represents Marty. All right, well, every time I see a y, I can replace with 180 plus 2w. So here's a y. I'm going to replace it with 180 plus 2w. So when will they be the same? So go ahead and solve for w. Now if I move 2w to the other side, I get -3w equals 180, and then I move 249 to the other side. Okay, I'm going to get 23 weeks. Okay, so it says how many weeks will they weigh the same? 23 weeks. Okay, well, after 23 weeks, what's their weight? So you got to take 23 weeks, put it back. I'll just put in for Jose, because the whole point is that they're going to share the same weight. I don't need to plug it back into both of them. So 2 times 23. They both be 226 pounds. Okay. All right, and it said, what if Marty and Jose wanted to gain 1 pound a week from their original weights? So here is Marty, here is Jose. And Jose is 180. Marty is 249. And they wanted to gain 1 pound a week. When would they weigh the same? So this is more logic based. When would they weigh the same? So they're starting at 2 different points. Jose weighs less than Marty, but they have the same rate of change. Those are supposed to be parallel. Are they ever going to intersect? No. So never. If they both keep gaining 1 pound a week. Okay, well, obviously they'd probably stop, but they wouldn't weigh the same. All right, and lastly, it says when both equations are written in the same form, when they mean same form, usually it's in standard form, an X, a Y, and a number, but it doesn't have to be. This method would be best, okay, using the elimination method, meaning to eliminate one of the variables. So I want to eliminate X or Y. Well, I see here this is a 2 and this is a 3. They don't cancel each other out if I add them down. If I add them down, I get a 5. This is a -2. But if I could somehow make this a +2, if I added them together, the Y would disappear. So I'm going to take this whole equation, and that's what's so cool about equations. You can do whatever you want as long as you do it to the other side. So if I multiply 2 to this side, that's fine as long as I multiply 2 to this side, and it keeps my equation balanced. And then I can eliminate the Y variable. So when I add down, I'm going to get 7x plus 0 equals 21. That means x is 3. And usually people like this method the best. It depends on the numbers if it's easier than substitution. So if x is 3, what's y? Like I said, you can plug it back into either equation. It shouldn't matter because the whole point is that they share it. So let's just try the bottom. 3 times 3 minus 2, y equals 5. So 9 minus 2y equals 5. -4, y equals 2. So it's 2, 3. My equation is consistent, independent, because we only share one value. All right, here, we have to put both of them in standard form. So I'm going to rearrange it by bringing x to the other side. And I got rid of y before because it was easiest. If I look here, let's get rid of x. If I just multiply this by a 2, and this will become a -6. If I have a +6, I want a -6. So we multiply, and we get these two. So this is going to become 0 plus, 0 equals 25. So that's fine. Does 0 equal 25? If it did, we'd say many solutions or consistent dependent, but this is not true. Therefore, no solution. They wanted us to classify, so we say inconsistent. And that's it. You can always go back, pause, feel free to email me or ask me any questions, but your homework's just going to be graph, substitute, and use elimination. And I will post the homework. It's a worksheet. It's not in your book. And I'll also post the answers to it as well. There's going to be a homework quiz on this. And there will also be a problem or two like this on your final, which will be also in your final review. If you have any questions, let me know. Thanks, guys.